Hello, and welcome to Backer Breaks It Down. This episode, we look at segments related to a circle with a focus on those segments created by two intersecting chords. So the Chord-Chord Power Theorem says, if two chords of a circle intersect inside a circle, then the product of the measures of the segments of one chord is equal to the product of the measures of the segments of the other chord. What? I know that's what you're thinking, huh? All right, so this green chord over here has been split into two smaller segments, A and B. So A times B is the product of the measures of the segments of that chord, okay? And then the blue chord, you have segments D and C. So C times D is the product of the measures of the segments of that chord. Okay, so let's apply this. You can see that it's really not that hard at all to use the Chord-Chord Power Theorem. So one of my chords is this chord here. So one of the segments is 12, the other one is X. And then my other chord is this one right here. The two segments are 10 and 6. So I'm just going to use my Chord-Chord Power Theorem to create equations. So the product of the measures of the segments of one chord. So if I'm looking at my yellow chord, I'm talking 12 times X. This is equal to the product of the segments of the other chord. So 10 times 6 is 60. I do the math and I get that X is equal to 5. Yeah, that wasn't bad at all. So let's see if I can make it bad. Ha ha ha, I'm kidding. Let's throw some algebra in there, shall we? All right, but I am still working with two intersecting chords. So one of my chords is this one right here. And notice the two segments are X and X plus 8. And then my other chord is made up of two segments, 5 and 4. So I'm just going to create an equation using my Chord-Chord Power Theorem. All right, so I'm going to take the product of the segments of my yellow chord. So I'm going to go X times X plus 8. And then this is going to equal the product of the segments of my other chord. So 5 times 4 is 20. Okay. Now I should definitely distribute over on the left side. So go X times X is X squared. And then plus X times 8 is 8X. And since this is a quadratic equation, I want to get it equal to 0. Because once it's equal to 0, then I can go about solving it. This one I think is pretty easy to solve via factoring. Okay, so I get it equal to 0 and I get X squared plus 8X minus 20 equals 0. And then it's time to factor. And this is one of those easy to factor problems because all I have to do is think what multiplies to be negative 20 and that adds to be 8. So I believe I've already done this work. See? So I got that 10 times negative 2 are those factors. I wrote out my factored form. So I have the quantity x plus 10 times the quantity x minus 2. So algebraically, there are two solutions, negative 10 and 2. The negative 10 doesn't really work, though, because how can a segment be negative 10 units long? Like, it can't. So x is 2 is our answer. So that's the Chord-Chord Power Theorem. It's pretty easy to use. You just have to find the product of the segments of each chord, set those two things equal to one another, and solve. And that's how Backer breaks it down.